Welcome to the first unit of the course that deals specifically with machine learning. In this unit, we will have two segments. The first one that you see here will not include any Julia code. We'll just discuss some important topics, some concept of machine learning. While the second segment will implement writing code. And we start our journey from an algorithm that the name is perceptron. And this is a linear classifier that historically has been a bit a pioneer in machine learning algorithms. Why we start from it? Well, because mainly of its simplicity. So we can really analyze in details what it does. And it will be the only algorithm for which we will do that. The other more modern algorithm that we will see, we will only have some intuitions. While for this one, we really go deep and see how he does, not only what it does. So let's frame a little bit the problem. If you remember, machine learning from the kickoff meeting has several areas, and here we are in the realm of supervised machine learning. That is it. We want to learn a relation between some characteristics that we know of the data and some other that we do not know and we want to predict. This could be some characteristics of our data that we don't know, or can be something that will happen in the future. And to learn this relation between what I call X and the Y, so the feature and the labels, we have some data for which we have both. And so we can supervise our algorithm with the data that we have and somehow teach the algorithm the relation between X and Y. Depending on the kind of prediction, we can make regressions when we want to estimate a continuous value, or we can make a classification where the Y, the labels that we want to estimate, are restricted in a finite set of possible values. So here we are with perceptron. We have in the classification kind of task. And more specifically, we limit ourselves in a dichotomic classification, in a binary classification, where the labels can get only two values. And for numerical reason, we are going to label these two values as -1 or +1. But of course, doesn't matter whatever label we give it. But important is that there are only two possible values. So we study in details this situation, that is the most simple. However, it is easy then to move on from this binary classification to a more generic classification where we can have various strategies based on these binary classifications. The feature that we are... So this concern only the label. For what is concerned the features, they are numerical, so they are continuous, and they can be possibly very highly multidimensional. So what the perceptron algorithm is? The algorithm is a method to find the parameters of a linear classifier that minimize the classification errors. At this point, what is a classifier? A classifier is a linear classifier is a hyperplane that divides the space into two parts and claims that all the points on one part are on one type, are classified of a given type, and all points on the other part of the space are classified with the other way. So this hyperplane is again nothing else than a plane in n generic dimension. So if we take two dimension, as here the hyperplane is a line. You can think if we are in 3 dimensions, it's a real plane like you are normally used. If you are in 4 dimensions, yeah, we are always the hyperplane as n-1 dimension. So here you see the boundaries of the hyperplane represent the boundaries of the classification of the space that is classified, and here you see the norm of the plane. So everything that is on this direction of the norm is positive, and everything on the other direction is negative. So what can we deduce from this figure? If we are in 2 dimensions and we have these classifiers, what is doing? Well, we can see that it's still making some error, these classifiers, because we have here one point that is misclassified. However, this point here in 2 dimensions shown, they are linearly classifiable. We can put a line here, so it would be enough just to turn this classifier a little bit more like here to classify the points without making any error anymore. So what the perceptron algorithm is nothing else than an algorithm that tells us how to rotate this hyperplane in order to minimize the classification error. So we will start from one hyperplane, and we provide the data one at a time, and with this data one at a time, we make many at each time, possibly a rotation, till we find a position, and we find the parameters of the hyperplanes that minimize the error. And for simplicity, we will work with classifiers that pass through the origin. We don't lose in generality, as we can always think of the constant term as just another dimensions where the future data is all filled with ones. So we can work with classifiers passing through the origin. It's up to you. You can keep this. What we are going to use here is not very efficient, because we will have to modify the data, the future data every time, to add a column of ones to represent the constants. Or you can work with an algorithm where the hyperplane is made by the parameters plus the constants. We will use the first method here for simplicity. So our first problem is to decide how to define the classifier, how to parameterize this hyperplane. And then the second problem is how to decide if it classifies a record correctly or it makes classification mistakes. So concerning the former, the way we parameterize the hyperplane, we define the boundary given by some parameters theta as the set of point x for which the dot product between x and the parameter theta, that are 2 vectors of the same length, is equal to 0. So x is d-dimensional. Let's gonna keep d as the number of dimensions, and same is theta. So wherever the inner product is equal to 0, this point x is on the boundary of the hyperplane with parameter theta. Given this one, it results that all points x for which the dot product is positive are classified positively, and at the same time, all points x for which the dot product is negative are classified negatively. At this point, for a given record, we can check if the classification that we obtain with the dot product match the label of the record, that again we just call it here minus and plus 1. So we have a very simple formula now to understand if the classifiers make an error or not. On one side we have the dot product, on the other side we have the label. If these two match, because they are both positive or both negative, we have a product that is higher than 0. If they are one on one negative and one positive, or the opposite, we have a negative product and we have an error. Not here, but is minus. We define here an error wherever this product is less or equal to 0. That is it. When a point is exactly on the classifier, we consider it as still being an error. At this point, we can do this for all the points and just count the number of error and divide by the number of points. So here we are just to compute the overall classification error of the classifier. We sum all the points, and here is nothing else than an indicator function. So indicator functions set a 1 when this is true, so when this here we have an error, and 0 otherwise. So here we are just counting the number of classification errors and we divide by the number of points.